A group of darkened parchment fragments from Qumran Cave 4 carries an ancient Aramaic version of material now associated with the astronomical Book of Enoch. One manuscript, 4Q208, belongs to the early Hellenistic period. That physical fact matters because it proves that Enochic celestial traditions were circulating in Jewish antiquity long before the complete Ethiopic manuscripts known today. And the text gives a striking answer to the question in the title. In 1 Enoch 72 through 82, the sun and moon are described as traveling according to fixed laws, rising and setting through ordered portals at the eastern and western edges of heaven. The sun changes portals with the seasons. The moon follows its own measured cycle. Their movements are presented as part of a divinely regulated celestial system. But one caution is essential. The text is not a scientific description of a modern atmosphere, and the word firmament can import assumptions that the surviving Enochic wording does not always express in the same way. What the text clearly presents is an ancient cosmic architecture in which heavenly lights move through appointed routes. Then the details become harder to explain. Why are there 6 portals in the east and 6 in the west? Why does Enoch connect the moon's changing light to precise fractions? And why does this strange celestial map also function as a calendar? The fragments survive. The system survives. But what kind of universe did its authors think they were describing? The surviving evidence is more complicated than a single Book of Enoch. What we call 1st Enoch is a collection of several works preserved together, and the celestial material forms the section commonly called the astronomical book, now numbered 1 Enoch 72 through 82. Its transmission is unusual. The complete form of 1 Enoch survives in Ge'ez, the classical language of Ethiopia. But at Qumran, Cave 4 yielded Aramaic manuscripts of the astronomical material. 4Q208, 4Q209, 4Q21, O, and 4Q211. Conventionally labeled 4, Q Inister A through D. They are parchment manuscripts written in square Aramaic script. Their paleographic datings are not identical. The Israel Antiquities Authority classifies 4Q208 as early Hellenistic, 4Q210 and 4Q211 as Hasmonean, and 4Q209 as Herodian. That spread matters. It shows repeated copying across generations, not one isolated manuscript, and it places the tradition securely within the world of Second Temple Judaism. Yet, the Aramaic fragments do not simply give us the entire Ethiopic section word for word. They are damaged, incomplete, and in places preserve material whose relationship to the later Ge'ez form requires reconstruction. Scholars therefore distinguish the ancient Aramaic witnesses from the much later complete Ethiopic transmission. The evidence establishes continuity of an astronomical Enoch tradition, but not perfect textual identity at every point. Within the Ethiopic text, chapter 72 opens with the ordered movements of the sun and its eastern and western portals. The following chapters extend the system to the moon, stars, winds, seasonal changes, and calendrical reckoning. So the question is no longer whether ancient readers possessed such a scheme. They did. The harder question is what the earliest recoverable version of that scheme actually looked like before centuries of transmission carried it into the form we can read today, in surviving textual form. The first major clue is hidden in the way the sun is described, not as wandering freely across the sky, but as obeying a repeating sequence. In 1 Enoch 72, the text states that there are 6 portals in the east and 6 in the west through which the sun rises and sets. Its position changes over the year. At one stage it rises through the 4th portal, then advances through the 5th and 6th as the days lengthen. Later it reverses the sequence as the days shorten. The description is schematic. Day and night are divided into 18 parts, and the changing balance between them marks the seasonal cycle. At the longest day, the text assigns more of those parts to daylight. At the shortest, the proportion is reversed. This is not modern solar astronomy, but it is an attempt to encode repeated observation into an ordered celestial system. Then comes a detail that gives the image its strange physical force. The sun does not merely appear at different points along the horizon. In this cosmology, those points are imagined as actual portals of heaven. The luminary comes forth through one opening in the east and enters another in the west. Elsewhere in the same chapter, the sun is described as returning toward the east by a northern course after setting. Some scholars understand this as part of an ancient model in which the observable motion of the sun is mapped onto a structured heavenly architecture. The text itself does not explain the mechanics in modern physical terms. It describes what the visionary is shown and how those motions are regulated. That distinction matters because the famous firmament claim is often made more confidently than the evidence allows. What First Enoch clearly gives us is a heaven with gates, fixed routes, measured intervals, and appointed cycles. The portals are textual features, not archaeological discoveries. But if the sun's path is already this carefully measured, the moon creates a deeper problem. Its light changes, its timing slips against the solar cycle, and the author still insists that both belong to one precise system. How did that system try to reconcile them? The moon forces the system to become more elaborate. In 1 Enoch 73 and 74, the text states that the moon also rises and sets through celestial portals. But its behavior is not identical to the sun's. Its light increases and decreases in measured stages, and its monthly course shifts in relation to the solar year. The description uses fractions to explain illumination. At the beginning of the month, only a small portion of the moon's light is visible. Over successive days, the illuminated portion increases until fullness, then declines again. The wording varies across translations because the numerical scheme is difficult, but the basic pattern is clear. Waxing and waning are treated as ordered quantities, not random changes. Then the calendar enters the investigation. The astronomical book repeatedly emphasizes a year of 364 days, arranged in a highly regular structure. That number is significant because 364 divides evenly into 52 weeks. The result is a calendar in which festivals and dates can recur on the same weekday from year to year. Similar concern for a 364-day calendar appears elsewhere in Second Temple Jewish literature, including texts associated with the Dead Sea Scrolls. But the lunar cycle does not fit neatly inside that structure. 1 Enoch 74 describes a difference between lunar reckoning and the 364-day solar scheme. The text is trying to account for the fact that months measured by the moon do not produce the same annual total as the calendar it considers correct. Scholars have debated the precise arithmetic and textual reconstruction, especially because the surviving witnesses are not equally complete. This makes the portals more than cosmic scenery. They participate in a system for organizing time. The sun marks the progression of seasons. The moon marks changing months. Their movements are watched, counted, and fitted into a calendar whose regularity appears to carry religious importance. Yet that creates a tension the text cannot simply ignore. Real lunar months do not obey a perfect 52-week year. So if the heavenly order is exact, why does observable celestial motion seem to resist the calendar built around it? One small translation detail changes how the entire picture should be imagined. English versions often describe the sun as passing through portals or gates, and that language can easily become a picture of literal holes cut into a solid dome. But the text does not give a technical description of what those openings are made from, how thick the surrounding heaven is, or whether they should be understood as physical apertures in the modern sense. The surviving tradition describes gates of heaven. That is more precise than simply saying the sun travels through the firmament. This matters because firmament carries baggage from other biblical passages and from later attempts to reconstruct ancient cosmology. Genesis 1 uses language commonly translated as firmament or expanse, while 1 Enoch's astronomical book develops its own elaborate vocabulary of heavenly gates, courses, chambers, and appointed movements. Similarity between these images does not prove that every author imagined an identical cosmic structure. The distinction becomes even sharper when the sun's return journey is considered. After setting in the west, the text describes it as traveling toward the east by another route before appearing again. The observer never sees that hidden passage. It belongs to the visionary explanation of what happens beyond ordinary sight. So the portals perform two functions at once. They correspond to changing points of sunrise and sunset along the horizon, but within the narrative they also belong to an unseen architecture governing celestial motion. A translation choice can therefore turn an ordered visionary system into something far more mechanically specific than the text actually states. And if the gates are not straightforward descriptions of holes in a solid dome, what physical observations could have inspired such a carefully structured celestial map? Modern astronomy offers a useful comparison, but only if the categories remain separate. The ancient text describes heavenly portals. Modern astronomy describes the apparent motion of the sun and moon through geometry, orbital mechanics, and the observer's position on a rotating Earth. The two systems are not the same. Yet one observational feature helps explain why the Enochic model could seem persuasive. The sun does not rise at exactly the same point on the horizon every day. Over the course of the year, sunrise shifts gradually northward and southward between seasonal extremes. Sunset does the same in the west. To someone tracking these positions carefully without telescopes, clocks, or modern coordinate systems, the horizon itself becomes a natural measuring instrument. Imagine marking repeated sunrise positions against distant hills, stones, or architectural sightlines. Over time, distinct zones emerge. The sun appears to enter the sky from changing locations, pause near an extreme, then reverse direction. A system of numbered eastern and western gates can function as a conceptual way of organizing those recurring positions. The moon is more complicated because its cycle is shorter and its rising and setting positions vary according to several overlapping motions. Its phases also change continuously. That complexity helps explain why the astronomical book devotes such attention to fractions, illumination, and differing cycles. This does not prove that the Enochic portals originated from systematic horizon observations. The text itself presents the knowledge as revelation shown to Enoch by the angel Uriel. Modern astronomical parallels cannot establish how the ancient authors believed that knowledge was obtained, but they do show something important. Behind the visionary architecture lies attention to real recurring phenomena: changing day length, seasonal solar movement, lunar phases, and the difficulty of making different celestial cycles fit a single calendar. The mystery, therefore, becomes more precise. The issue is not whether ancient observers noticed the heavens accurately enough to recognize patterns. Clearly, many ancient cultures did. The question is why this particular tradition transformed those patterns into 12 celestial gates governed by angelic instruction, and whether those gates were primarily a cosmological belief, a mathematical device, or both at once. The conflict becomes clear when the calendar leaves the page and enters religious history. The astronomical book does not present its 364-day structure as a neutral curiosity. It treats the motions of the heavenly lights as part of an ordered system, and that order has consequences for how sacred time should be measured. Within Second Temple Judaism, calendar questions were not trivial. Different Jewish groups used different methods for determining months, festivals, and the beginning of the year. Texts from Qumran show a strong interest in fixed calendrical schemes, including a 364-day year. That does not mean every Qumran community member read First Enoch in the same way, or that one manuscript dictated the calendar of the entire movement. But the overlap places Enochic astronomy inside a real historical dispute about sacred chronology. Later Jewish tradition did not preserve First Enoch as part of the rabbinic biblical canon. Early Christians, however, knew the work. The Epistle of Jude explicitly quotes 1 Enoch 1:9, and writers such as Tertullian later discussed Enoch directly. Yet reception was uneven. Some Christian authors valued Enochic traditions, while the book did not become part of the biblical canon in most Christian churches. The major exception is Ethiopia. The Ethiopian Orthodox Tewahedo Church preserved 1 Enoch in Ge'ez as part of its broader scriptural tradition, which is why the complete work survives today. Greek fragments and other ancient witnesses confirm that the text circulated far beyond Ethiopia, but they do not preserve the entire book. There is no evidence that a single council erased the astronomical book because of its cosmology. Canon formation was slower, regional, and shaped by many factors, including language, liturgical use, theological preference, and textual transmission. Centuries of copying therefore created an uneven record abundant enough to prove circulation, but too incomplete to reconstruct every community's understanding with confidence. That history leaves an uncomfortable question. If the celestial system was once copied, read, and debated across different communities, why did this detailed map of the sun and moon survive completely in one tradition while becoming fragmentary or marginal in so many others? The present-day mystery begins with absence. The Aramaic astronomical manuscripts from Qumran are real, ancient, and physically preserved, but they are fragmentary. Large portions are missing. Lines break off. Columns survive only in pieces. In some places, scholars can compare surviving Aramaic wording with the later Ge'ez text. In others, reconstruction depends on damaged letters, parallel passages, and the structure of the calendrical system. That creates a difficult problem. The complete Ethiopic astronomical book is much later than the Qumran fragments, while the Qumran copies are much earlier but incomplete. Neither witness can simply replace the other. One manuscript, 4Q209, preserves extensive astronomical material, including calendrical calculations. Yet even this text survives in fragments. Some reconstructed passages have been debated because tiny differences in numbers or wording can alter how the system is understood. The evidence shows that a sophisticated Enochic astronomical tradition existed in the Second Temple period. It does not give us every sentence of its earliest recoverable form. Modern photography, multispectral imaging, digital reconstruction, and improved paleographic comparison can sometimes make faint ink easier to study. But technology cannot restore words that physically disappeared from the parchment. A blackened edge or missing strip is not a hidden archive waiting to be unlocked. Even a single lost numeral can change the arithmetic scholars are attempting to recover. So the central uncertainty remains textual. Did the earliest astronomical book already contain the same arrangement of portals, numerical cycles, and explanatory details found in the complete Ge'ez tradition, or did parts of the system develop as the work was copied and transmitted? The fragments can narrow that question. They cannot yet close it. And until they do, every reconstruction of Enoch's celestial machinery must confront the same silence: what exactly was written in the spaces that no longer survive. Now, an important distinction is necessary. The physical evidence proves that ancient Aramaic manuscripts containing Enochic astronomical material existed at Qumran during the Second Temple period. The textual evidence shows that this tradition described the sun, moon, seasons, and calendar through ordered gates, measured cycles, and appointed movements. But neither fact proves that the heavens are literally constructed according to the cosmology described in 1st Enoch. The manuscripts are evidence for what ancient communities copied and transmitted. They are not scientific measurements of the universe. The surviving Ge'ez text preserves a far more complete version of the astronomical book, while the Aramaic fragments provide earlier witnesses to parts of that tradition. Scholars can compare them, identify continuities, and reconstruct damaged passages cautiously. But reconstruction is not the same as recovering every original word with certainty. Interpretation begins when we ask what the gates meant. They may reflect an ancient attempt to organize the changing positions of sunrise and sunset, a symbolic architecture of heaven, a calendrical framework, or several of these functions at once. The text itself presents the system as revelation given to Enoch. Modern comparison with seasonal astronomy can clarify why certain observations make sense, but it cannot prove the visionary claims. Speculation begins when those observations are turned into assertions that Enoch possessed hidden modern science, or that the Qumran fragments verify a literal, solid firmament. The evidence does not establish either conclusion. If the early Aramaic tradition already contained a structured system of eastern and western gates, and if those gates corresponded, at least in part, to repeated observations of changing solar and lunar positions, then the larger question becomes whether the astronomical book preserves a religious cosmology built around disciplined observation rather than a simple myth detached from the sky. That possibility does not reduce the text to science, and it does not elevate it into modern astronomy. It places it somewhere more difficult to classify between observation, calculation, revelation, and sacred time. and that is where the surviving fragments become most unsettling. They do not confirm the universe described by Enoch. They confirm that real ancient scribes carefully preserved a system they considered worth copying, even when its full logic is now partly lost. In the darkness of Qumran Cave 4, the surviving parchment fragments remain the strongest anchor in this investigation. Their edges are broken, their lines preserving only pieces of a larger astronomical system. Yet those pieces show that Jewish scribes of the Second Temple period copied a tradition in which the sun and moon moved according to fixed celestial routes. The complete Ethiopic text lets us see that system more fully eastern and western gates, changing day lengths, lunar phases, measured cycles, and a 364-day calendar. But the fragments remind us where certainty ends. They do not prove a literal solid firmament. They do not reveal every word of the earliest version. They do not tell us exactly how every ancient reader understood the gates. What they preserve is more restrained and perhaps more intriguing evidence that observation of the sky was woven into sacred cosmology and transmitted for generations. The parchment still exists. The calculations still survive. And the gaps are still there. So when those ancient scribes pictured the sun disappearing through the western gates and returning unseen toward the east, were they describing the universe as they believed it truly was, or a symbolic map designed to make the heavens measurable